Hello, my name is Fritz Burkhardt, and we're going to be going through Horse Racing by Jack Franken. Now, in this case, we are hosting the Microsoft Excel Horse Derby. In all of these cases, one of the first things that we want to do is we want to take a look at these bonus questions and see if there are any which we can answer quickly to be able to get some fast points. And so if we take a look at bonus question 1, it says how many horses are included in the racing horse details table? So if we head over to the horses tab, we're going to press control page down twice to move to the right. We can take a look at, hey, how many horse names do we have? I want to highlight all of the horse names by holding shift and control and pressing the down arrow. And if we look down here, what we're going to see is, hey, we've got a count of we've got 90 horses. So we could just come back to our case by pressing control page up twice, and we could just type in 90 and we'd be in great shape. If we wanted to use a function, we could use the count function. If we're to use the count function, we're going to come back to our horses tabs, but for us to count, we need to count actual numbers. So we're going to take a look at the base speed right next to the horse names, and we're going to highlight all of it by starting up and then pressing Control Shift down all at once here, and we're going to also see 90. So hey, we've got bonus 1. We're in great shape. For the second question, it asks us which horse has the longest name. Include spaces when counting the length of horses' names. So we're going to go back to our horses tabs, and rather than counting each letter individually, we're going to use the len, the len function, where the len function, it asks us to provide a text for it here. So we're just going to point to the horses' names. The length of Galloping Gizmo is 15 characters long. We want to bring this all the way down, so we're going to press Control C. I'm going to move one to the right, Control down, one to the left. Control Shift up allows us to have everything along here and allows to put in very quickly the length for all of them. Now what we want to do is we want to figure out which one is absolutely the largest, and then we want to return the horse name next to it. So to be able to do that, a great function is going to be the XLOOKUP function. The lookup value we're looking for is we're looking for the maximum length within all of those lengths. And what we would like to return is we would like to return the horse name next to it. So what we will see is the horse with the longest name is Whimsical Whirlwind. That gets us to bonus question 2. Let's take a look at bonus question 3. Which horse's base speed is the slowest? This means the most seconds required to run a furlong. So what we want to do again is use our XLOOKUP, but our lookup value is now going to be the maximum, not of the length, but the maximum of the seconds per furlong is what we'd like to pull in. And where we're going to look that up, we're going to look that up in that same location. And then what we'd like to return is we'd like to return these horse names again. We keep pulling these horse names. And since we keep pulling these horse names, one thing which we might want to do is actually to name this particular range, because we keep using these horse names over and over again. So I'm going to highlight from B3 all the way to B92, and then I'm going to move up to this upper left. And up here, I'm going to type in horse names. So whenever I want to refer to this particular area, we can just type in horse names. Let's look at bonus 4. How many horses are slowed down by both water and mud? Horses are slowed down by a surface if the speed change is negative. So let's go across to our horses again. And what we'd like to do is we'd like to check here. It's like, hey, is this something where it slows down? So we're going to use our if function. And since we're testing two things in our logical test, we want to use the and function. If both our speed change in water is less than 0 and our speed change in mud is less than 0, then let's put up a flag. Let's put up a value of 1. And if not, we'll put up a value of 0. So we're going to see, hey, Galloping Gizmo isn't slowed down by both. It's only slowed down by one of them. Twilight Tango is slowed down by both. So, hey, we want to grab that horse. I'm going to do Control C, Move over, bring this back here, and we're able to get each one of them to figure out for each one, are they slowed down by both? And then what we want to do, since we want to count all of them, we want to sum up all of that array that we just made. So we see, hey, there are 58 horses. There are 58 horses that are slowed down by both water and mud. If we look at bonus question 5, if all horses competed in one race, which horse would win? This references level 6. Let's hold off on this until we get a little bit further. Let's hop to level 1, gauging the speed. How long does each horse take to travel 1 furlong, 1 cell in seconds? So we've seen that in the horses tabs. We want to use our X lookup again here. The lookup values, we want to pull this particular horse name. And what we'd like to do is we'd like to look for Poppy Popcorn. We want to look for that in the horse names. We just named that range. So that's the array where we want to look things up. And what we'd like to return is we'd like to return the speed. So get to C3, shift control down again, and we're able to get, hey, Poppy Popcorn speed is 6.0. Now, one thing here which I look is, hey, you know what? I didn't lock these cells. We're going to have to put in an F4 to put the dollar signs in front of our C3 and our C92 so we can copy this formula sensibly. If we then copy it up to look to see, hey, does it work in Sunny Skipper? Yeah, it does. This looks good here. So now what we're going to be able to do is we're going to be able to copy this down, and we're going to be able to fill all of this nicely. We've got part 1 set. Let's move to part 2, the first race. Given each horse's base speed, how long will it take to complete the 50 furlong race here? Well, do not include the impact of water or mud. Just use the horse's base speed. Well, we've just grabbed this base speed up above. Let's bring this down. This is how long it takes each horse just to go one of the cells. But we're not just going 1 cells, we're going 50. So let's multiply this by 50. And then we're going to be able to get the speed. Let's then come back up. Let's check with Clever Cloud. Hey, that 350 works. Go down to our 980, 1 to the left, control down, 1 to the right, control shift up, and then we're able to place all of it. We've got 2. We're all set. Let's go to 3. Mapping the track. The race starts out at the starting line on the racetrack tab and ends in the finish line in cell BA2. For each section of the track, determine whether the section is filled with water, mud, or dirt here. And then it says, example, what's section 21 from? So let's go and let's take a look at our racetrack. So hey, here's our racetrack. And what I want to do is, since this one's pretty quick, I'm actually just going to type in dirt for all the dirt cells that we have in the first one, and just copy this across here. So I'm using the arrow keys and then shift in the arrow keys when I want to highlight more than one. And then, hey, we're able to put in all of the dirt. Let's then go and let's put in all of the water. So I'm going to type water in the first one, shift in the arrow key across for water. Let's go get the other water pieces. And that's all the water. And then let's type in for our mud. Since there are not a ton of them, typing it in isn't going to take us that long. And we're able to get absolutely everything that we need up here. Now what we're going to do here is we want to be able to pull something in. Now, when we're pulling this in, we've used XLOOKUP before, but another great function that we can use is we can use index. Index allows us to pull from a particular array referencing the row number and the column number. For our array, we've just made an array which has all of the names of dirt, water, and mud. So I want to highlight all of these here. And then I'm going to press F4, so we're always referring to our racetrack. That puts a dollar signs in front of our C and the 2. So we're always pointing to this as we copy this across and we copy this down. For our row number, hey, we want the first one. And for the column number, hey, that's where we want the track section. So what this will do is it will give us within the array, hey, in the first row of our array, in 45 across, it tells us, hey, in that spot, we're going to see dirt. Let's copy this up. And hey, look, hey, in the 21st, we see mud. This is working brilliantly for us. So let's come on down. Let's put all of this in, and we're able to get, hey, our dirt, water, dirt, mud. if we want, we can take a quick look to make sure this is behaving properly. If I want to look at 41, I'll look at the racetrack. Hey, at 41 over here, I am seeing that we've got mud. So hey, I'm happy about that. We're happy with 3. Let's go to 4. Picking up speed. What is the speed of the horse within the given track section? Include the impact of water or mud here. So if we look at the example here, hey, the new example of Nimble Nighthawk is 12.96 here. The base speed was 16.2, and it's filled with mud, causing a minus 20% impact. So it actually seems like it's making them go a little bit faster here. So let's take a look at here of what the speeds are going to be. Let's put this together. So we're going to have it, hey, with our dirt, our water, and our mud. So we can be able to say, hey, what are the speeds on each of the surfaces? So on the dirt, we're just going to take the base right here. For water, we're going to take our base speed. I'm going to press F4 until I've got my column locked, and allow the row to fluctuate, times 1 plus our speed change in water. And hey, we get our 14.4 for water, and our mud, we're still at 16. We've got this set up. We'll bring this all the way down here. So we've got our speeds based upon these different surfaces. Now, we want to be able to look this up. I've got the track section right here. I'd actually like to say, hey, what surface does that actually correspond to? Because we just did that up here in section 3 by using our index. We can use our index again to be able to refer to this particular array. You'll notice that when we get to the end, BA through B6 are a merged cell. So it had to move back up, so we're not grabbing that. We just need the first row, and for our column number, we'll take which track section that we have right here. So hey, the 24th track section, that's water. Hey, the 44th, that's mud here. And so we're able to get the surface for each of the track sections that we're looking at. And so at that point, what we can do is now we can pull the information about, hey, what's Peppy Ponytail's speed in water? Now, when I'm matching on 2 dimensions, I actually really like to use the index. So for our array, let's go to what we have here for the horse's speeds on these various different surfaces, and let's lock it. For our row number, what we want to find is we want to match. So I'm going to use our XMatch command. And what I'd like to look up is this particular horses, where this horse is, and where I want to look it up, I want to look up that horse within our horse names. And we want to match this exactly. So we're going to put an exact match of 0. And that's going to put in the row, hey, where does this particular horse show up? For our column, we want to match, and what we'd like to match is we'd like to match this particular surface. We'd like to match the water. We'd like to match the water across the surfaces that we've put up here. We'll again want to make sure we lock it by pressing our F4, press comma 0, close this up. And when we close this up here, we're going to be able to get, hey, what is the full speed here? Hey, Peppy Ponytail in water is going 6.88. Let's copy this, check on Nimble Nighthawk. Hey, that works. So we can bring this all the way down. And so, hey, section 4 is complete. Let's go to section 5. Around the track. Calculate the time it takes for a horse to complete the full track in seconds. Include the impact of water or mud. Do not round any interim calculations. Round your answer to the nearest second here. So if we want to go around the track here, and we do need to round this to the nearest second, what I'd like to do here is I'd like to say, hey, what's the total time that it's going to take to get around the track? But now we're going to actually have to pay attention to, hey, how many dirt, water, and mud sections we have. But we can go and we can count this. We can use this by using a count if or a count ifs here to say, hey, let's take a look at how many of this range with this particular criteria are actually dirt. And what we're going to see here is, hey, there are 31 which are dirt, there are 12 which are water, and there's 7 which are mud. So we're going to need to take, hey, 31 times our dirt speed plus, 12 times our water plus 7 times our mud. But what I'd like to use here is I'd like to use our sum product command. Our sum product allows us to take two arrays and it allows us to multiply them by each other, where what it's going to do is it's going to take the number that it sees first in the first array and going to multiply it by the number that it sees first in the second array. And then it's going to add to it, hey, the number that it sees second in the first array times the number that it sees second in the second array, plus the number that it sees third in the first array times the number that it sees third in the second array, and so forth here. But in this case, what we've got is we've got our dirt, water, and mud, is that this is set up so that this is horizontal. The data that we have over here, hey, this data over here is vertical. And if we're using our sum product, if we've got our horizontal, we want to be multiplying it by also a horizontal. So I'm going to flip this one from vertical to horizontal by using transpose. Transpose moves us from horizontal to vertical, or from vertical to horizontal. And we also want to make sure that we lock these cells when we refer to our counts of dirt, water, and mud on our racetrack, so we're always pointing to those. And then we can bring those down, and that's going to give us our total time for each one of the horses. So what we could do again is, hey, we could do our X lookup. We're going to look up our bold bandit within our horse names. And then what we're going to return is we're going to return this total time. Now the thing here, it says, hey, round your answer to the nearest second. So what we need to do is we're going to need to put a round outside this here. The round is going to give us the number. Hey, that's the time that we wanted in here. And then what we're going to do here is then we're going to put 0 to be able to put it to round this to the nearest second. The other thing which we need to do here, since I was moving a little quickly, we need to make sure we lock our horses' times here so it comes down properly. So I'm going to copy this up. Hey, is this working? Hey, this is 338. This is 342. And then we're able to have everything nicely rounded to the nearest second here. So, hey, we're in great shape. We have all of this for 5. The last thing which we have is we've got level 6 here. Which horse will win the race here? Among the 5 horses in each race, the horse with the lowest time to complete the track will win the race. But we just have figured out a way that we can get the amount of time that it takes each horse to go around the track here. So let's actually just pull that out, and let's just pull this out right to the side here. I want to use an X lookup of Frosty Falcon, and I want to look that up in our horse names again here. And what I'd like to return is hey, how long it's going to take Frosty Falcon to make it along the way. And again, if we press our F4 here, it puts the dollar signs, and in here it's going to make our lives a little bit easier. We've got Frosty Falcon, it takes 5:30, and I'm just going to copy this across to the right. And what this is going to give us, it's going to give us how long it takes for each one of these particular horses to make it all the way around. I'm going to bring this up and down. And then what I would like to do is I'd like to use an X lookup, where now this time we want to look up the minimum, the one which takes the least amount of time to make it around. So we're going to find, hey, where's the minimum of these times within these particular times? And then what we'd like to return is we'd like to return, hey, which of these 5 horses is the fastest? It says, hey, it's Energetic Echo. Let's go up, check here. Hey, we've got Giddy Gallant. Hey, this is working quite nicely. Let's bring this all the way down. So we've brought this all the way down. We're in absolutely great shape. We've got 6 done, but we still have that one bonus question. So let's go back and let's finish that one up here. So if all horses competed in one race, which horse would win? Well, the horse that's going to win is the one which is going absolutely the fastest. So we're going to use our XLOOKUP one more time. And what we want to look up is the one with the lowest amount of time. So we're going to look for the minimum. We're going to look for the minimum of the total time, looking that up within our total time, and then we want to return the horse names. And what we're going to see is Poppy Popcorn is the one which is absolutely the fastest. So with this, we've been able to go through, we've been able to check our answers with the example 1, 2, 3, 4, 5, 6. We've been able to use our XLOOKUP, our index, our count, sum product, our len, a lot of other great functions. I hope this is helpful for you in your practice. If you have any questions, please don't hesitate to reach out. Thank you very much, and happy Excel esporting.